Thank you everyone for coming here. I am super excited to be here. I've done a lot of work in my basement and in my office, and I'm actually here and can talk to people about it. So I'm super anxious, but I'm super excited. Smile for the photo. There we go. Thank you. All right, so my talk today is called Embracing commonMain for Android Development. If you don't know what commonMain is, it's basically the source set that you can use for multi-platform to compile out to all the different targets. I myself am a Android and Kotlin GDE, and I currently work at Dropbox with some other wonderful people here in the audience. And yeah, love to get started. So this is, embracing commonMain for Android development and really like starting to use that. You could actually say this is Kotlin Multiplatform for Android development, but we'll kind of get in there. So there are two big articles that happened related to code sharing on Android. One is the Airbnb article that came out a long time ago regarding React Native and how they gave that up. There's also this one at Dropbox, and hey, I work at Dropbox now for a little under a year, about code sharing and the not so hidden cost between the two. So Dropbox had C++ code sharing for a long time that they gave up. And so this article is kind of interesting because it doesn't call out C++ in the title at least. It calls out just the cost of code sharing. And that exists pretty much with anything that's out there. So definitely read this article, it's very important. It's really a lot of good ideas. But what I want to do is kind of talk to this from where I see multi-platform for Kotlin. So one of the big quotes in there says this: by writing code in a non-standard fashion, we have this overhead that we wouldn't have to deal with if we had used the platform defaults, and it becomes more expensive than writing the code just twice. I think that that Kotlin is a standard now, so we're something that we're using on Android every day. So it's not something where we're having to make our own frameworks to wrap C++ so I can go ahead and work it in this project or in that project. It is a standard thing, and so I think there's a lot more promise there. More expensive than just writing twice. It kind of depends. I think we're going to get there, but it depends on every project that you're in. But I think we're much better off than we were with C++. One of the big things is, we had the great talk earlier by Russell about Kotlin multi-platform settings. There is an ecosystem for building libraries for Kotlin multi-platform. It is only growing. One of the things that Dropbox built during the time of C++ is this framework called Djinni, D-J-I-N-N-I. And so it's like the JNI framework that you could use from C++ over to Gradle. And then you also had one for iOS as well. And it was this custom wrapper they had to build and maintain. And so that sort of thing is what the Kotlin team is building, right? That is Kotlin multi-platform. We have an entire team at JetBrains fully dedicated to that. So when we talk about these custom frameworks and libraries, it's a first-party thing. This is what they're building. This is their thing. So we're not talking about one company's little hack thing, right? So everybody's contributing libraries. There's a great amount of them out there. And so I think that's really what's going to make this successful. The custom development environment, this still exists in some ways, but when you're an Android developer and you're writing this, you're using IntelliJ, you're using Android Studio, and this is what you use day to day. It isn't custom from that perspective, but we're talking about a code sharing solution. So it is kind of a custom environment coming in from the iOS side, and we have to think about this. This is a code sharing solution. This is for all mobile developers, but from half of that side of the mobile, it's just what it is already. So addressing the difference between platforms, Kotlin multi-platform can kind of choose the things that it wants to do. It's not trying to do something like React Native did that really takes over all the UI as well. You have the ability to do actuals and specs, or expect, or you can pass in an interface like we talked about in some of the other talks earlier, so that you can address the differences. But if you write your code in commonMain and you have those abstractions for the other pieces, then you're able to go ahead and write a ton of your code that can be shared across platforms. And as these libraries and the ecosystem gets more and more, it's just going to kind of be there. Available to you. Training, hiring, and retaining was something else that they called out in the article. I think it probably helps hiring. There's companies here saying, we do multi-platform, come hire for us. I think it's great. So it's easy to hire Kotlin engineers because every Android engineer is a Kotlin engineer now. And so so these were the main 4 points. The other thing was the big quote out of it, and I think that Kotlin addresses almost all of them. It is still a foreign environment from iOS perspective. I know there's work being done there, but I think it has a big chance. So if you ask me, when will you use Kotlin multi-platform? The answer is this, right? It's a shruggy. So I'm using it today in my side projects, and this is kind of me answering on behalf of Dropbox in a way. it's kind of a shruggy because we're not going all in, but I'm very interested in it. I see a big promise, and so I want to start exercising this muscle and building up things so that we have an opportunity to use it. In this talk, I'm trying to I looked closely at how we can start adopting it without risk. And that's what this talk is about. So I've actually created a Gradle plugin that I'm gonna share here that's got a snapshot version out right now that will allow you to use multi-platform with absolutely zero risk. So I'm hoping if you're interested in it, in your project, you can find certain modules, you can go ahead and start converting to multi-platform, testing it, playing with it, and it can put you on that journey. And if you continue to choose to keep going there, that's great. If not, it was just a little configuration you had to deal with. But if you do, there's gonna be these points in time when it's like kind of serendipitous or whatever, where it's like, oh, we already have this thing available, it's multi-platform, let's go use it. So I think if you try to force something, it's gonna be hard, but I think there will be opportunities. And so I kind of call out here, it'll be organic, right? Like, we'll have the right opportunities. It's a lot easier on a new project you're doing. Like with Dropbox, we've been around for over 10 years on our mobile app, so like we have all the main foundations of things. So it's harder to kind of start things there, but there's other newer apps and things we might build that would be able to benefit from it sooner. So yeah, going with that analogy of organic, let's plant a seed and see where it takes us. So we're writing the exact same Kotlin code we were writing already. The difference is the Gradle plugin, and that's kind of what we'll get in here. Instead of the Android or JVM plugin, you're actually just using the multi-platform plugin. By doing commonMain code and using this, you're kind of forced into modularity, and it kind of makes it a little bit easier to test things. And the thing I like the most is it makes you think about the other platform. Before this, like I had dabbled around in Xcode, but in trying to get this to work, and at my previous employer, which I won't name right now, I did get Kotlin Multiplatform to ship. And in doing that, I really had to like experience the iOS side. I think this is super important. Like, I don't want somebody coming with me and saying like, here's this Rust SDK, it's awesome, go use it. And I like don't know how to do it, I don't know Rust, I don't know how to debug, I feel like that's not fair. And so I feel like the story and the tools for working on iOS are great, but I can see from an iOS developer perspective when this starts, that's kind of what they're seeing, right? It's like, here's this binary, go use it. So I think the more that we can work with iOS developers and like kind of understand where they're at and like what they need and the Swift interop and things like that, it'll end up working out better. So I feel like this gives us a chance to be more mobile developers than just Android developers, and I'm really excited about that. So what is the cost of doing this, right? So in this world, I'm trying to talk about how we can get into multi-platform. And with this plugin I built, it stonks. So I'm gonna talk about how much investment it is. It's basically some configuration overhead, and then what you choose to use for libraries, but it could really pay off. You could have an opportunity when you're like, hey, there's a new app I wanna build, and we need an iOS and Android, and immediately you could like bring this over and get it to work. So commonMain is the ultimate source set of Kotlin Multiplatform because anything you write in there can compile out to any of your targets if there's support for that. So that was said in Russ's talk earlier. He said, hey, if you write it in Common, it works and it can go to both. And then there's platform code that's specific that you have to like kind of augment in. But as we get things like SQLite, for databases, we get KTOR for networking, we have Kotlin serialization for serialization and settings, multi-platform settings. These things that need the platform dependencies are kind of filled in for you. So you're able to write that common code that allows you to move over to these things. Again, another person here talked about how you have your common code and it goes out and basically the main thing here is commonMain. Let's embrace it. Let's write our code in common because the more you can write there, the more it goes to all the platforms. If you haven't written it before, this is what it looks like. So you typically have your source directory in your Android or Kotlin Java module, and you'd have your main folder. In this case, it's just commonMain. You additionally have your platform folders. You have iOS main or JS main or whatever other things you want to target. But that's pretty much the only difference. That file in there is a Kotlin file, and it can just compile to JVM like it normally does, or it can compile to multi-platform if it's commonMain kind of compatible. Right now, if you use the Android plugin, you have a main source folder. When you compile it, it goes through the Kotlin compiler and generates Java class files. If you use the JVM plugin, that's actually like kind of what's happening underneath the hood for the other one. You have your stuff in main and you're bringing over. If you use sorry, my brain's not working there. But yeah, if you go ahead and use the multi-platform one, then you're going ahead and you're having the common code that you can just point at the JVM. Or you can actually go ahead, like all those other things showed, and you can point it at other multi-platform targets. So let's talk about how we can like adopt this using some Kotlin Gradle plugins that I'm talking about here. So we have Kotlin Android, Kotlin JVM, Kotlin Multiplatform. When you use the Kotlin Gradle plugin and you apply it to the class path, you have all these already. They're already all there. So if you're using an Android project or just a Java project, you use those. And with both of those, you use main as your source set. With multi-platform, you use commonMain. That's pretty much it. So let's actually get past that. OK, so again, in a Java one, you'd have main and you have test. But so these are source sets, but then also there's a configuration that goes along with it. So inside of this, because you only have a main, like there's no concept of different platform types, you just have one dependencies block. It knows I'm just talking about this main source set. Inside of there, you can say whether it's a test implementation or implementation. But when you move into the multi-platform configuration world, for your common main or your common test, you describe things differently. And additionally, in multi-platform, you define what targets that you want to support. In this case, I'm saying this multi-platform project is actually only targeting the JVM. But what's different, instead of having like implementation or like test implementation and things like that, for each piece, so for common main or common test, you're actually calling those out as an implementation. So instead of saying common test implementation here, you're saying implementation under common main. Anyway, common test. So write once and run everywhere. I don't know if you can see this in the very corner. It says yes, but ... The main thing I want to call out is just multi-platform is still under development. We have, as I mentioned, the Kotlin team is like completely behind it. I've talked to a bunch of people there. Like it is a main priority, and it's going, but it's under development. So I can see like, at a company like I'm at, or other companies, like it might be something that we're not ready to jump 100% into. But I find it very interesting. I think there's a huge future for it. And with this mechanism I'll show you in here, we can like start using it and trying out and making Kotlin multi-platform compatible code. So if we want to make that jump, we can. Other things, like if we use multi-platform and don't configure it correctly, it can be super slow. There's ways that's described in this article, which is pretty nice, that you can enable and disable like iOS targets via Gradle flags, so you don't actually have to compile to iOS every time. You maybe just target JVM. So I definitely recommend something like this. Multi-platform currently does not support configuration caching. Josh Feinberg on my team just implemented it, and it went down from like 40-minute builds to 40-second builds to 6-second builds. It is just amazing. And if we had to give up configuration caching, it wouldn't cut it. So what I want to do is I want to have it so that we can still use this, but then also fall back to have everything that we know is like not, underdeveloped. It's more stable, so that we can continue to use that going forward. Additionally, this is very small, but like this is on the left, a Kotlin JVM project. On the right is a Kotlin multi-platform project only targeting JVM. And this is a Gradle build scan. It's just kind of showing that like there are more tasks. There's kind of overhead there. So all these things kind of like, it's under development. All these things are happening. It may, in a large organization, you might have this risk, and it may just be like, I'm never going to use multi-platform because they're not going to let me, because there's so many things. But with this strategy here that I'm going to show in this plugin, you can do it because you mitigate that risk, but you still get to try multi-platform. So what can we do to use multi-platform with zero risk? Zero, star there as well. So I took this concept. I said, you know what? Like, I really want to do this in this code base. There's a lot of code in here. Where do I get to start? So I took my shopping app project, which is my like open source project where I dabble around, and I like thought, okay, it's just Kotlin code. A lot of the stuff right there was already using just like standard libraries and things like that from from Kotlin. So what I figured is like, it's just in the main folder. Why can't it just be in commonMain? Isn't there some way to like map that over? And so what I did here with this like proof of concept was I took all the code. Anyway, I changed some configuration over so that it could flip back and forth. And so once I did this, I was able to like kind of, with one line change, swap over to be multi-platform compatible or back, but it didn't quite work. And the reason being, in a multi-platform world, the top of it has to be common main. And what I had done is I had made main so basically like as it went up, it would be like JVM and iOS, common main, and then main. And I had done it that way, but in multi-platform world, it doesn't understand that. So what I did is I reached out and talked to Sebastian, who's on the multi-platform team at JetBrains. And we met on Google Meet or whatever for about an hour. And he told me that, and we worked on it, and we figured out how to make this happen. So I've kind of run with that. I've cleaned it up a whole bunch. And out of all that, I now have this like plugin that's a little bit more self-contained and kind of works in most cases. So it is called KMP for free, because that sounds awesome. At least I thought it did. And it does, that is what I'm looking for here, right? It's like, I already have Kotlin code, but I want to make it multi-platform, so why can't it be free? And so, you know, there's a snapshot published right now. I'll probably put out something stable here soon, but I'll show you it working today. I'm going to do some live demos. All you do is if you have like the plugin, the Kotlin JVM plugin, you just change it. So you change it to handstand KMP for free. And by doing that, you enable this magic. Once you have that plugin enabled, there's now a Gradle property that you can turn on and off. So if you say KMP for free is true, it'll enable the multi-platform plugin. If you say KMP is equal to false, the opposite. And with Gradle plugins, or Gradle properties, you can pass them in on the command line as well if you want to do it different that way. So the JVM project structure that we've talked about has main and test. This is what happens when you have it toggled to off. And so this is exactly what you have right now. Nothing, like the only difference that's changed is using my plugin that just basically applies the JVM plugin. That's it. However, if you turn it on to true, this is in Android Studio, and you can see there's brackets on the side there. I'll kind of highlight both. It says next to it commonMain next to the main folder, and it has JVM test next to test. So behind the scenes, when I talk to Sebastian, there's basically Kotlin source sets and configurations, and it's doing some like mapping to move them to the other spot. So the code actually sits in that main folder. It has not moved, but the configurations have moved so that it believes it's part of commonMain. So that's the way that we're kind of getting away with this, right? Like we've taken our code, we haven't moved anything, so there's like no risk. But if I flip this thing on, I now have multi-platform code. So how? Yeah, like I mentioned, source set and configuration mapping. We could go deep in there, but even when I look at it again, I'm like, what? But yeah, in the README file, I try to do my best job of kind of explaining how it works. And actually, we do have some slides coming up, I forgot. So primary goals of this is a zero risk, no risk, single line change to enable multi-platform. I wanted to make it easy for you on your existing code that you seem like, oh, this uses standard libraries or just uses like Kotlin X serialization. Why can't this be multi-platform? To go ahead and give it a shot. Another thing is I want you to stop using, I don't want you to use this forever. I want to use this to try. I want you to like start exercising that, but then I want you to go use the multi-platform plugin once it gets stable. Like you should move there. You should just be targeting the JVM with multi-platform. But this is your stepping stone. And in order to do that, I'm providing backwards compatibility. So it's not just like you have your main source set and it moves over to commonMain. You can actually specify in multi-platform configuration and it'll put it back into a JVM style project. So like you specify everything as multi-platform, but it'll actually just run the JVM plugin. So it does mapping in reverse as well. And so yeah, I just wanted this to be able to have experimentation and potential migration to multi-platform. It lets you start doing it now. So when you have it on, the source set mapping does these two things. So it takes everything that was in main, maps it over to commonMain, like kind of as you saw in that Android Studio screenshot. Configurations, if you had something as implementation, it maps it over to commonMain implementation. Because if you just switched out JVM to multi-platform, it'll error out and say like, I don't know what implementation is, because that doesn't exist in that world. But anyway, this mapping magically makes it work, right? And same with test implementation. I've made a deliberate choice here of having test implementation actually map to JVM test implementation. The reason for this is like, I want you to try out doing multi-platform and writing commonMain code, but I don't want you to have to worry about updating your tests as well. It's like another hurdle to come over. So what this will allow it to do is continue running it on the JVM, but only worry about moving over your main code, or all your normal code over to commonMain. And then additionally, I added some task aliasing in this. I'm up for debate, but like if you're running something in CI, you're just on a Java module, you're saying run test. But because the multi-platform plugin is there, that test task is no longer there. So if you ran it in CI, it might not work with this on. So I added an alias so that if you run test, it actually runs a JVM test. So it just gives you more of that flexibility to go back and forth. If you turn it off, like I mentioned, it's like this backwards compatibility where you can start writing things in a multi-platform configuration, but have it map back over into a JVM configuration. So yeah, it's like this. And then same thing, you're going backwards on the configuration mapping. So anything that's commonMain implementation comes back to implementation. I think you get the general idea now, right? So it's like we're mapping over one way, we're mapping over back the next way, but basically we're just cloaked, and like if it's off, I look completely normal. So it's a really, I think it's really cool. All right, this is my migrating to commonMain funnel. So the way it's supposed to work is like the top is like, has more things and the bottom has less things. So at the top, an Android library has class files, basically a jar file, but it also contains an Android manifest file and it contains resources. So maybe like, drawables and whatever else, strings and stuff like that. If you just cut it down a little bit, one less thing is a Java library on the JVM. And on that, you just have a bunch of class files. If you go down one less than that, it's a bunch of class files in a jar file, but it's only Kotlin code, right? Because in an Android project, you can have a mix with Java. In a JVM project, you can have a mix with Java. But if you get to a Kotlin JVM, it means I have only Kotlin code and I'm only compiling to the JVM. And then finally, if you just go down to multi-platform commonMain compatible code, it goes there. So like as you go down, there's like, you're more limited in what you can do, but if you create layers of abstraction, you can start writing code in this way. You're already doing this right now, by the way. You're limiting yourself in order to get some benefits. So if you're writing Android tests, you may find they get slow. I have to run them on a device, I have to do other things. So a lot of us think like, how do I run these on the JVM? Like some people start using roboelectric tests, or maybe you write interfaces to abstract out certain things that are platform specific on Android. The same thing here, like you could take something that was an Android test and like kind of just isolate it so that you can run it on the JVM. And it's typically faster. So let's get into the demo of CamP for free and just show you this thing working, because I'm, many hours in a basement after hours, and now you get to see something built. It's great. All right, so what I have here is, so this is, if you clone the project on GitHub, this is what it is. I have a samples directory. Inside of here, I have an Android app, an Android lib, JVM. So JVM here actually just is a Java library. I just called it JVM, and then a multi-platform one. What I want to do today is like take you through the experience where you're already in your code base, and you want to take some of your stuff and start migrating it over. So if you were to do this, and we look back at these slides over here, if you, like, there's this funnel, right? Like, coming down. Like, how many layers do I have to go through to get to something that's commonMain compatible? And the thing right above the bottom is Kotlin JVM. So I'm going to show you a module that is Kotlin JVM, because then we don't have to worry about getting rid of Android dependencies, and we don't have to get rid of Java code. Like, what's the closest thing we have to commonMain now? So if I look at that, that's what this module is here. So in JVM, obviously this is an example, it's trivial, but we have JVM lib, and it has, just two simple things. It has a list, and it has a class name. And this works great. It's a Java thing. It's a Kotlin, here we go here. It's a Kotlin JVM project. But you know what? Like, this is pretty close to multi-platform, right? So why don't we change it over to do this? So I have an example of one below that's already using the plugin. I'm going to steal it, and we're going to add it up here. So now I've done it. I'm going to sync, and watch this here. Nothing happens. That's good. That's good. So what we can do is we can come down, not that part, and in our Gradle properties, we can toggle on CamP for free. We'll do true, and then we'll do a Gradle sync. Now watch this. Ooh, main just became commonMain, right? One thing happened there, right? So now we have Kotlin Multiplatform compatible code. For this project, I kind of have it already set up so that it can target iOS and Android based on these flags that I pass in. Kind of like I mentioned earlier, make your builds a little faster and only build for what you need. So I could go ahead now, and I did Gradle W, samples, JVM, samples, JVM, assemble. And guess what? It's going to work. But it didn't actually build for iOS. What I have to do then in this case, and the reason why I'm showing this is I would really suggest that you enable or disable targets via the command line, or via properties. So if I go ahead and enable it to true, I can sync it, I can build it, and we will get, errors. So it's saying here like unresolved references. And you saw it work just a second ago, right? But the reason why it's failing now is because in the configuration for multi-platform, it's configured to also build for iOS. And so if we go back in this project now, I open this, something's different. It's red. You know what that means? It means it's not commonMain compatible. So now, if I want to go through each one of my libraries and kind of see which ones can be compatible, I can turn this on. And it shows me right in the ID, like this thing isn't multi-platform compatible. So what can I do? Like a lot of the times, and this is like the trivial example here is, there is an equivalent already in the Kotlin standard library. So I can just do list of. I do that, and then I get rid of my arrays. Because that's a thing part of the Java standard library. We didn't need that. And so in this case, we're using the Java name. I can go ahead and use the Kotlin built-in thing and just say class.simplename. This just uses Kotlin reflect. But yeah, it's available. It's multi-platform. So now I can go ahead and run it down here and watch our Gradle stuff. Ooh, linking debug framework for iOS. So we just took a normal Java project, and let's look at our Git history here. So we took a normal Java project. We flipped on KM for free for true, flipped on iOS. All we did is a one-line change, and then we updated our code. And now we have multi-platform code. Like we have common code. And so, I could go ahead and commit this now. I just go ahead and turn back off my flags, and it's going to compile just directly to the JVM. So I want to show you that in the plugin. So this is the KMP for free plugin. When you apply it, it goes out and says this Boolean value is multi-platform enabled, which is just that flag. Is KMP for free equal true? So if it is, it applies the multi-platform plugin. And then this is, I call it KMP for free magic because it's all the source set mapping and stuff, but it works well, and when you look in there, it makes sense. So it goes ahead and does that. Otherwise, if it's off, it's only going to apply the JVM plugin. So that's what I'm saying. It's like zero risk. You have this one abstraction where it says use this plugin, and then just only use JVM. So then enabling the Kotlin JVM does that backwards mapping so that we can do something like this multi-platform KMP for free, where inside of here, I actually have multi-platform configuration, but it's actually able to go compile straight to the JVM. So that's an example there. Secondarily, if we move up the funnel, we have Android libraries. And the most of you are going to have just like Android libraries out there. But you'll find that a lot of those Android libraries don't need to be Android libraries. Or there's a lot of it that doesn't have to. So you can do some refactoring. And so when you get in there, you might find, you know what, I could just replace this with, so yeah, like what I was mentioning, you want to go through Kotlin JVM, find all those, because they're probably the easiest thing to move based on that funnel, right? It's like only one step down. But most of your stuff's probably going to be Android. So you can start looking at that and see, based on the dependencies that you see in there, in this case for the Android one, we're only relying on the standard library. So this should be good, right? So we can go in here and do the exact same thing we did for on this one. So we'll come up here. Instead of these two, we'll change this over. So this means that the Android plugin is no longer working, and our support for Kotlin Android is not working. So this essentially is doing is just turning on the Kotlin JVM plugin. If I run this right now, it will fail because it still has Android configuration, and it doesn't know about that. But because, when you look at this project, if you look at the Android manifest, it doesn't do anything. It doesn't really need to be an Android library, right? And you'll find this a lot of the time. Yeah, there's just not much going on here. So we should be able to go ahead and convert that over. So I'll comment this out, and then we will run it again. And we will find out that everything is great. So everything works great. There's commonMain there now in the Android library. The Android manifest file is still there. It doesn't hurt anybody. But I do not have support in this KMP for free library to go back and forth between Android code and back. Like if this was you could make this basically first a Kotlin JVM project, and then you could go toggle back and forth. But whenever you're an Android library, you have platform-specific code. So you can go do that if you want, but this platform doesn't do it. In this whole thing, if you want to do this, or if you're doing it, please just message me. I'd love to collaborate. Like, as I mentioned, it's me in the basement or talking to some people on Zoom, so I'd love just to see what people are doing on this. Cool. So yeah, let's go ahead and build this one then. So we use the terminal. This one is called Android lib, so we'll change that out. 3 Android lib build, and oh, it failed. Oh no. I'm sorry. So in this one, I wanted to show an example of something that wasn't just the standard library. In this one, it's date. And part of the Kotlin standard library does not include date. What is available that does date-like things is the Kotlin X date library. So in this project, if I choose to use the implementation, and I already have this in my version catalog. So I did libs, Kotlin X, and then .datetime. Then what I can do is start using that. So I'll sync so it's available in the IDE. We'll come back over here, and I want to replace this. So I can't use Java util date, but this thing here is giving me like the milliseconds or since the epoch or whatever it is. So I can do clock.system.now. It's either nanoseconds or I think it's epoch milliseconds. So that would be the equivalent. I could obviously test that. But now, since I've moved that over, everything works. So I now have another library that I've migrated over. And you might say, like, these are very trivial, right? But it's the step. It's exercising that muscle. It's trying to see what we have already. I think the benefit more so might be is when you're building new things and you're starting to make decisions of, like, should we use Kotlin X or Kotlin X date, or should we start using SQL Delight? I did a talk at DroidCon New York City 2.5 years ago now, a long time. But I basically, in using SQL Delight, I liked it better than I liked Room. And that was just my choice as an Android developer. I knew it was multi-platform compatible, but I hadn't done any multi-platform. And so, like, I'm finding that more and more libraries, like Kotlin X serialization, I'm like preferring that even maybe over like JSON or versus Moshi. So like the good news is a lot of these choices that are multi-platform compatible are already one of the top choices. So it's not like you're giving up anything, you're using a Kotlin library you'd want to use. So that just kind of shows you what you can do in here, yeah, going forward or backwards. So let's wrap this thing up. All right, demo, we did that. All right, so KMP for free is a low-risk way to explore Kotlin multi-platform. Please go explore it, go try it, let me know, I'm curious. Is it really free? No, like we talked about. There's configuration in here, there's some digging, there's the choices that you make of what library you're gonna pick. Like if you use JSON, you're not gonna be able to do serialization right off the bat. But if you use Kotlin X serialization, yes, you have that multi-platform option. So when you start choosing libraries, consider that. Is multi-platform something I wanna check out in the future? If it is, try to find a library that is compatible. Big thing here is test and experiment. Just getting this to work is cool, but when you see it running in iOS, when you see it running in the web, then you like get really excited. It's really fun. And you're like, oh, this is great. This is gonna take over the world. And then you put yourself in the shoe of an iOS developer and you go, wait, what? And so I did that at the previous company I was at. Like I had to work with the iOS developers, and luckily I knew them really well. I gained trust, and I got in there, and I figured out how frameworks work, how static frameworks work, dynamic frameworks work, what an XC framework is, what's a Swift package, what's CocoaPods, and like all these things. But as you step over the fence, then I understand what Swift UI is. I look at what the interop looks like from that side, and I can understand their pain points, because in order to make multi-platform work, we have to have iOS developers contributing to multi-platform, to the Kotlin code. If we don't have that, it's a one-way thing, and it's always gonna be the Android team's problem, right, for writing it. So that's why I think this KMP for free idea, like I said, it's just like, it's a tool to get us somewhere, is the way that I would suggest people approach it, right? It gives us an opportunity to start exercising that muscle. It's under development, but it will be stable in a year or two or however long it takes. And I think it puts us ahead of the game. We're already building code that's multi-platform compatible. So thank you very much. Dropbox is hiring. We have 9 open positions right now. The referral bonus is doubled. Hit me up. We have to hire soon. Anyway, but thank you very much. I really appreciate it, and thanks for listening.